Another day, another story. In computer programming, a loop is a fundamental construct that allows a piece of code to repeat itself until a specific condition is met. Loops are essential for creating efficient and powerful algorithms, and they come in several different forms, including for loops, while loops, and do-while loops. One common question that arises in the context of loops is whether a loop can be considered an actual infinite. In this video, we will explore this question and provide an explanation of why a loop cannot be considered an actual infinite. To begin, it is important to define what we mean by an actual infinite. An actual infinite refers to a quantity or set that is truly infinite, meaning it has no limits or boundaries. It is a concept that has been debated by philosophers and mathematicians for centuries, and its implications are profound. For example, some argue that the existence of the actual infinite leads to paradoxes and contradictions, while others believe it is a necessary concept to explain certain mathematical and philosophical ideas. With this definition in mind, it is clear that a loop cannot be considered an actual infinite. While a loop may repeat itself many times, it always has a finite number of iterations. In other words, a loop is bounded by the condition that must be met for it to terminate. This condition may be a specific number of iterations, a Boolean expression that evaluates to true or false, or some other logical condition, but it always exists. Consider the following example of a simple for loop in Python. This loop will iterate 5 times, printing the values of I from 0 to 4. While it may appear that this loop is infinite, since it repeats itself indefinitely until the condition is met, the reality is that it has a finite number of iterations. Once I reach 5, the loop terminates, and the program moves on to the next line of code. Another way to think about this is to consider the fact that a loop is a construct created by humans. It is a tool we use to solve specific problems and achieve specific goals. While the number of iterations a loop can perform may be very large, they are always finite and limited by the capabilities of the machine running the program. No matter how large the number of iterations is, it can always be expressed as a finite number. In conclusion, a loop cannot be considered an actual infinite. While it may appear that a loop repeats itself indefinitely, it is always bounded by a finite condition that must be met for the loop to terminate. As such, loops are a powerful tool for computer programmers, but they are not a manifestation of an actual infinite. Understanding this distinction is crucial for developing effective and efficient algorithms that solve real-world problems. Thanks for watching.